We have enough time to talk about capacitance. Now, we're going to charge up these capacitors, and I'll talk about what that means in just a moment. This capacitor we're going to charge up to 2,000 volts. That's going to be right here. Okay. And this capacitor bank here is the one that's deadly. And this is how I lost my hearing, this one here. And
Should I be covering my ears here?
what's that?
Should I be covering my ears right now?
It's not going to go off for a while, so you're going to be fine. Actually, last period, it was very disappointing. We came in and we found there was a bunch of oil leaking out of this one here, and the boom that we had was about half as loud as it normally was. And I suspect that someone, last time they used it, may have damaged this capacitor here, and so instead of 2 in parallel, we just have 1 in parallel. I truly apologize. But we're going to raise that to 3,000 volts, and it's going to take a while. It didn't take nearly as long as it normally does in the last class, and that's why I suspect that one of them is damaged. But for people in the front row to watch this gauge, I'm now using the top scale, and when it gets near 3, you got to wave and get my attention and get me to turn this off, because if it gets past 3, we destroy the other one as well. Okay. Let's blow up some capacitors. The first one I'm going to blow is a 2 microfarad capacitor. It stores, if you use that formula, 0.004 coulombs. And I think you'll agree that, no, come on. Now don't you feel silly? Okay. Now, this one has 100 times the capacitance, except I think one of them's broken, so I think maybe it just has 50 times the capacitance. At any rate, now you should. Chat YouTube. Can you imagine when it was twice that loud? Here's the thing. If I had charged that up and then just taken it right back to the demo room and put it on the shelf, left it there for 5 years, and then just told a grad student, hey, would you go give me that capacitor, man? Just go get it. They go down, they grab it, and they're just, bam, they're dead. Okay? This is the most dangerous thing in your demo storage room. And so you always want to check, when you approach one of these, you approach it with a paddle. And you make sure that it's got the positive and negative terminals sorted out. And then it's safe. Don't ever just grab one of these things without making sure it's safe first. Now, this last one is, I saved the best for last. This is one of those new tech ones with the dielectric in it that's 1 farad. And if I bring it up to 5 volts, this is 1 coulomb per volt, times 5 volts is 5 coulombs. So, and this has a very definite positive and negative because of the dielectric. And I've set this so that it will only go up to 5 volts. Okay? And so let's get this disconnected. Okay. Are you ready? Everyone ready? Oh, come on, people, it's 5 volt. It tingles, but it doesn't hurt me. Okay? And the key is, Yes, this does store more than 10 times the charge. But it's not the charge that does damage. Remember, energy is the capacity to do damage, and these capacitors not only store charge, they store energy as well. Now, if I want to calculate the energy stored in a capacitor, I could follow student 1, which is never a good idea. I know that the electric potential energy is given by the charge multiplied by the voltage difference, so I just multiply those two together. And student 2 is more right. That formula would give the change in potential energy of a test charge moving from one plate to the other. To find the total energy stored in the capacitor, I'd have to add up all the volt necessary to charge it up from 0. So far, so good. I would probably have to use calculus. When they say that, you know they're not using their imagination. That part's wrong. If you take the total charge and you multiply it by the average voltage that you have to cross, and that would, if I'm going from 0 to V max, that's just half V max. If I replace the Q with C delta V, you see that it depends on the voltage squared. And that's key. Voltage squared. If I go back to this example, I have 400 joules of energy in the big guy, and I released it all at once with the metal paddle. Here, I've got more charge, but I don't have nearly as much energy, and I released it slowly through my tongue that has more resistance. It tingles, but it doesn't do any damage to me. Okay? So it's the energy that does damage. Folks, I hope that you have a wonderful spring break. I hope you use sunscreen. I hope you come back safe. We love you all.
Greg, can you go back one slide? Can you go back one slide?